Okay, before we begin these three examples, pause the video and copy down the success criteria for finding slant asymptotes. Okay, let's start with the vertical asymptote. This should be pretty easy to see. You can also check to see if we can simplify this, but we actually can't. There are no factors of 27 that add up to 5, so there are no common factors. So the VA is simply going to be that 0 in the denominator, x equals 2. Okay. All right, slant asymptote. This is the new part. When the degree, notice they didn't say define a horizontal asymptote because it can only be one or the other. Because the degree of the numerator, n, has to be 1 higher than the denominator. Okay, so that means n is greater than m, right? Well, when n is greater than m, there is no HA. But there might be a slant asymptote as long as the difference here is just 1. Okay, so that's the condition you got to remember for slant asymptotes. If it's just 1 higher, and we see that, second degree over 1 degree. Okay, so, great. Now how do we find it? We divide these functions. We use our synthetic division, if possible, or long division down here. But we have to know to divide the functions. So this function is being divided by x minus 2. All right, so, you should be able to see that even though they're in a fraction form, but basically this is what's happening. Just watch or write this down if you want to. This needs to be divided by x minus 2. Remember, when we divide, and it's in the form x minus k, which this one is, we can use synthetic division. Okay, 2 is the k value. We don't use the minus. All right, so I'm going to put 2 up here in the corner box. Remember, this is always k. Goes here, the 0, if you will. All right, and then we got 3, we have 5, and we have negative 9. Add, multiply, and then add these. So we end up with 13. Okay, so now what do we do with this? After we divide it, this is the remainder. It's okay to have remainder. We're going to ignore it anyways for the asymptote. This is the constant. This is the linear term, right? Ignore the remainder. Drop it. Okay, this is the part we use right here. So there's a slant asymptote at y equals mx plus b. Okay, 3x plus 11. Okay, see that magic happen? So when you divide it, whatever you get for as a remainder, you can throw it out. This will give you the slant asymptote. Okay. All right. 9's very similar. Just careful. Now it's x plus 3. So now your k should be negative here. And then this is, backwards. So you might want to flip this around right away and call it negative 5x squared plus 4 over x plus 3. Once again, we can't really simplify any common factors out of this one, like the last one. I want to give you a moment to answer this. Okay, find the VA, find the slant asymptote, pause, give it a shot. Okay, here's your feedback on 9. Yeah, it is simplified. We can't factor it all. So the zeros of the denominator are negative 3. So there's your VA. Slant asymptote, I just got it ready. Y equals mx plus b. If you're messing up on the sign, just maybe rewrite this. X minus k. How do I write x plus 3 as x minus k? Minus negative 3. Okay, that's the same. And now that's your k value, okay? All right, don't forget the 0. We have the 0x term. You got to have that in there. Add, multiply, add, multiply. Okay, we can actually stop though at this point. We don't even need the remainder, but anyways, it's negative 41 if you found it. We throw this out. Okay, remainder, constant term, linear term. So this makes up my slant asymptote, negative 5x plus 15. Okay. Okay, last one here. 10. This one's a little messy on the VA. It's not usually quite this bad, so don't worry about it too much. I have a lot of this written down, so if you're writing it down, pause it to do it. But let me start explaining. We can't factor this one. There are no factors of 4 that add up to negative 3 because they'd have to both be positive or both be negative, and that wouldn't work. And this is cubic up here. We can't factor it, okay? So we could still find the zeros of the denominator. It doesn't have to be factorable. We'll find the zeros. We could use the quad formula since it's quadratic. Okay, So once we do, though, we just run into a problem. We end up with a negative here, so there are no real zeros. So what does that mean? So if there's no real zeros, then there's no vertical asymptote, okay? So there's no VA. All right, slant asymptotes. Like I said, that's going to be kind of rare for this scenario to happen. Most of the problems they give you, you can find them. And there are VAs. All right, so slant asymptote, though, this isn't as rare. This is going to happen. Once again, is the degree of the numerator 1 higher? Yes, it is. Third over second. So we have to divide these. Synthetic division, though, is out. You have to use long division. We should know that from section 2.3. All right, so what we have to do is take x squared minus 3x plus 4. Put that out front. 3x cubed plus 5x squared. I have a whole coming up. I'm going to put 0x plus 2. Okay, this is a good review problem. Last thing we're doing, pause. You give that a shot. See if you can long divide that. It should only be 2 steps. Okay, I'll walk you through now. Remember, we focus on the leading terms. X squared times what gives me 3x cubed? I'm going to need 3x. And then you multiply. This times that. Keep going. 3x times 3x is 9x, and I'm subtracting it. I'm going to put, 3x squared. So we have minus 9x squared. 3x times 4 is 12x. Subtract. Gone. 5 plus 9. 0 minus 12. Okay, carry down the 2. All right, and then it looks like we can only do this one more time because the degrees are equal right now. Okay, so x squared goes into 14x squared 14 times. Now multiply. 14 times 3 gives us what? 42. So that's minus 42x right here. And then 14 times the 4 is 56. Subtract. Gone. Negative 12 plus 42. That gives me 30x. 2 minus 56 is minus 54. Okay, now x squared doesn't go into 30x anymore, so we know we're done. This is the remainder, but what do we do with the remainders up here? For the slant asymptote, we disregard it. You don't have to worry about it. So we're going to throw that out anyways. Aha, here's the slant asymptote, mx plus b. So the slant asymptote is at y equals 3x plus 14. Okay, we'll stop there. The next page is graphing them. Hopefully we're back together to do the second day of this. Have a good day.